What is audibility? Welcome to our course on audibility and intelligibility. In this series, we'll continue on notification for fire alarm systems, but we'll turn our attention to the role of audibility and intelligibility for fire alarm systems. We're essentially following our natural progression, so to speak, as we would lay out a fire alarm system as a designer. So what is audibility? Audibility, meaning the noise we hear like a temporal three-tone, is required everywhere in a building that's occupiable. When we talk about audibility, we mean an increase in the sound level that's created by the fire alarm system. How well can the fire alarm system be heard? That's probably the key. How well can you hear it? Is it loud enough and distinct enough that people in a building are alerted and can take action? If we are going to achieve audibility, then we'll create a sound level that is sufficiently higher than our normal ambient conditions so that the fire alarm is heard and it's distinct enough for us to bring awareness and take action. So we have a few important concepts to talk about when we establish audibility. First is ambient sound levels. In a space that's in its normal condition, is it loud or is it very quiet? An office building will have a large variety of rooms and uses. A conference room can be very quiet when it's unoccupied and the doors are closed. There's often a fair amount of sound absorption with carpet on the floor and decent acoustic ceiling tile or ACT ceilings. That's why it makes a nice spot to take a private phone call if no one is in that room. That's a very different noise situation than if there's a yelling match between the corporate egos during a heated meeting. The sound level there could be, notably higher. That sound level is vastly different than if we were in a mechanical or machine room with operating equipment that creates a lot of noise. Regular sound levels in those environments could be so loud that we should have hearing protection whenever we enter them. Let's talk about building acoustics. I mentioned carpet and decent quality acoustic ceiling tile. Before getting into fire alarm design, I would have thought that any ceiling tile is about the same as any other. Well, it turns out they're very different acoustically, even if they mostly look the same. Same with other room properties. If we have soft, sound-absorbent materials, then tones are often more clear and they reflect the sound less. This would be carpet, curtains, acoustic panel, and other soft surfaces. If we have hard surfaces, sound can reflect and be difficult to distinguish, but it will also keep higher sound levels in that space. Hard surfaces like concrete, tile, and glass often reflect sound more than softer surfaces do. Acoustics aren't limited to just the materials, though. It's also affected by the shape of the room. Depending on the shape of the space, the volume of the space, and the shape can reflect or distort sound pressure waves as they travel. In other words, a gymnasium with wood floors, CMU block walls, and a metal roof deck above can have very large volumes that allow sound to reverberate. Distinguishing sounds in these kinds of spaces can be very difficult. On the other hand, a small recording studio with lots of absorbent materials like acoustic panels, carpet, and acoustic ceiling tile, those can help keep sound very clear. Intelligibility, which we'll talk a lot more about later in this course, is all about our ability to understand a message. Is a message intelligible or capable of being understood? Audibility is all about the sound level. Is it loud enough from our normal conditions to get our attention? Intelligibility is all about can we understand it? So then, where do we need audibility? Let's focus on that. In a nutshell, audibility is required for fire alarm systems in every space that's occupiable. Are there people regularly in the space? Is it a room? Audibility is required. Is it a warehouse area? Required. People will regularly be there. Is it an attic or an interstitial space with no storage? Not required. Is it a shaft? Not required. Again, people are not in there. Audibility is one of the clearer directives that we have for fire alarm systems. Does that mean that we have horns or speakers in every single space in a building? No, actually not. We mentioned that sound can reverberate on hard surfaces, but it can travel through barriers as well. A closed door will keep some sound out, but probably not all sound unless it's some kind of doomsday bunker door entry. Normal doors very commonly have a gap at the bottom for ventilation, and depending on the materials, it can allow plenty of sound through. If we have a small storage room and there's a horn in the hallway right near it, well, chances are we could actually achieve audibility even if that door is closed. The ambient noise in that space is going to be awfully quiet, and the horn nearby is going to be relatively loud. As long as that delta is big enough, the delta in the sound level, that one horn in the hallway could achieve audibility inside the storage room, even when that door's closed. So what is the amount? What does that delta need to be? In other words, how much increase in sound level do we need? Well, that's a great question. Thanks for asking. The delta is our guiding rule for audibility. We need to achieve at least 15 decibel, dBA, above the ambient sound level, or 5 dBA above the maximum ambient sound level that would last at least 60 seconds. Think of a small mechanical room that has a compressor. If that compressor kicks on and stays on for a minute or more at a time, we need to achieve a sound level with the fire alarm system that's 5 dBA above that maximum ambient sound. Otherwise, we still need to achieve 15 dBA above the average ambient sound level. If it's a sleeping area, fire alarm notification must be at least 75 dBA at the location that a pillow will be. Where does this come from? The IBC and NFPA 101 actually dictate this. In the IBC, it's from section 907.5.2.1. What happens if 15 dBA isn't achievable? What if we have very, very loud spaces? It doesn't do us much good to make a very loud space even louder. First, that's hard to achieve. Second, it might not set occupants up to be able to notice the difference. If we're wearing sound protection already to begin with, increasing the sound level in the space really doesn't help us much. So the IBC accounts for this too. We can't have a total sound pressure level of ambient plus all of our audible notification that goes over 110 dBA. That's taken if someone was 10 feet from the appliance or the minimum distance that the appliance has in its listing. If the ambient noise is greater than 105 dBA, we provide visible notification, that's our strobes, and audible appliances are not required. So think of that loud factory floor. If the sound level is already over 105 dBA, we use visual notification and don't add notification appliances. That might be strobe only instead of horn strobes or speaker strobes. So what about validation? After a system is installed, how do we know that it meets audibility? This isn't too difficult. For our temporal 3 strobe systems, this involves using a decibel meter to measure sound levels throughout a building. If the sound is at least 15 dB above the average ambient in all occupiable areas, well, if we've achieved that, we're good. One note here is that during testing, it's possible, but not likely, that we'll know the exact ambient sound level. That's because when we're testing, buildings are often unoccupied. It's extremely annoying for fire alarm systems to be continuously activated while people are working. So we usually coordinate our testing either when people aren't in the building or before the building's ever occupied. So we can get an average ambient sound level, but it might change once the building is fully occupied. How do we account for that difference? NFPA 72 actually gives typical average ambient sound levels for different occupancies. This is found in table A.18.4.4 of NFPA 72, at least in the 2025 edition. For example, business occupancies are listed at 54 dBA. Does this mean all rooms in a business occupancy will be at 54 dBA, with fire alarm needing to achieve at least 15 more, so up to, we would say, 69 dBA throughout all occupiable spaces? Well, not exactly, because average ambient sound level changes for each space. An open office area will have a different ambient sound level than a closed-door private office that's well insulated and far from mechanical rooms and elevators. But this annex table is helpful in establishing expectations for about what different ambient sound levels will be as a starting point. So who does the validation after install? Well, commonly, the installing contractor is responsible for it. So if an inspector challenges audibility in an area, having a calibrated decibel meter on hand can measure and address whether audibility is actually met. For horns, we often have a high and a low setting, so we could tap it up to the high setting. And for speakers, we often have a wattage setting, so we can up the amount of watts and it will be louder. This could help for audibility. If this doesn't work, we're probably looking at adding horns or speakers to the space in order to achieve audibility. Practically speaking, how are horns and speakers laid out? Personally, when I'm reviewing a set of floor plans, I'm looking to locate horns or speakers, and it's one or the other. So if we have a horn strobe system, we have horns. If we have a voice system, we have speakers. We want to locate those in as relatively few locations as possible to get audibility everywhere that's occupiable. So remember from our last series, we already started with strobes. We've already done our strobe layout. When I'm designing, I make each strobe a combination appliance. So again, if we have a horn strobe system, each strobe becomes a horn strobe. And for voice systems, each strobe becomes a speaker strobe. So then at this stage, I'm already going to have those locations defined on the plans. Now I'm looking for gaps. Where are rooms or areas that have no chance of achieving audibility based on those already laid out horn strobe or speaker strobe locations? I'll commonly find large storage rooms, large mechanical rooms, places like that that didn't need a strobe, but now need some help in order to achieve audibility. With those gaps, can I put one horn or one speaker in a central area that can cover multiple nearby rooms? Can I stick one speaker in an open office area that'll cover much of that space? That's the loose strategy that I'm using until I know that we'll confidently achieve audibility everywhere. In this segment, I've touched on audibility. It's a way to get people's attention to take some action. Audibility is a difference in sound level that needs to be loud enough and distinct enough so that occupants readily know that there's something going on. The most common rule for a fire alarm is to achieve 15 dBA over average ambient sound levels or 5 dBA above maximum sound levels that last a minute or more. If the combined sound pressure level is over 110 dBA or our ambient sound level is already 105 dBA, then we'll use strobes instead of audible appliances. I'm Joe Meyer. This is MeyerFire University.
This has been a preview of MeyerFire University. Join the next generation of fire protection experts at www.meyerfireuniversity.com.